Hi everyone, my name is Nikolai. Last time I installed servo on my milling machine spindle, and after that communication with my smart pendant stopped working. And in this video we will try to fix this. I had a comment that it is because I didn't install filter on servo driver power supply, but I doubt. And I have good reason for that. I will demonstrate it a little bit later, but first let's install filters and see what happens. So filters. First filter that I plan to install is this, of AliExpress, 3 capacitors, 2 inductors, and there's something else. And the next filter I plan to use this. It's a more serious one, heavy can, soldered all around. But a little bit scary, those terminals which open, and if it's touched it won't be really good. The schematic, and I plan to install this filter inside this box. It's a voltage converter, since my outlet has 120 volt and I need 240 for servo. I bought this converter. It's 1500 volt ampere, which should be enough for 1000 watt, 2 outlet for 240, 2 outlet for 120, and power switch. So this is what's inside. Not a lot of space. This filter unfortunately wouldn't fit, but this one would. It fits no problem anywhere. So, and this is the result. Filter output, I reused one wire from a voltage switch and added another one. Then it goes to this outlet. It's only one filtered outlet. The other outlet is same as it used to be. And I also added those wires that goes to filter plus ground. So I placed a converter here. Output that is filtered goes to this filter on this side, and ground also connected here. Then output, black and white wire, and also a ground purple wire goes here, and ground connected to servo driver, as well as those line inputs. Okay, let's turn it on. My lab in the basement, and this is our GFCI outlet for some pump. And as you can see, it's tripped. But weird thing is, it's only tripped if ground is connected to servo driver, which you should always do. Without ground, it can be deadly. The other options how to fix it: disconnect motor from a servo driver. So it's somehow related to current flowing through the motor, but obviously we need a motor. We couldn't do that. And another solution I found: if I disable any of those filters, it will work. For example, I remove from filtered outlet to non-filtered outlet, turn it on, and GFCI outlet didn't trip this time. But communication errors is still there. You could see blinking buttons and jumping numbers, so it didn't help. Maybe it's because just one filter in line. Let's try 2 anyway. So I moved this again to internal filter and this filter, and we will use this, which is connected to non-GFCI outlet. Don't worry, because if the current leakage, it may burn something, but for science, didn't blow anything. How about communication? And you can see it's still jumping. So 2 filters in line also didn't help. And as I said, filters didn't help. How did I know that? Because this is how I filmed those errors. Cable of pendant lays right on these power cables. And if I do this, like move cable out of the way, and even maybe move past grounded cabinet, the errors almost all gone. Almost, but not all. So it didn't fix the issue. Issues should be fixed with communication through this cable to be 100% sure that machine could be used safely. What's the plan now to fight those EMI? It's classic solutions. Shielded cable, twisted pair, and differential signaling. For the cable, for now, I will use twisted pair, category 5E, just Ethernet cable. It's shielded, it has 4 pairs. I need only 3 pair, for 1 for power and 2 for transmissions, but there are 4, so 2 pairs will be used for power and 2 for communication. As for differential line, I plan to use those modules from AliExpress. Those has transmitter, LED, some diodes, but I look on it and it's kind of big, so I designed my own modules to do so. It's way smaller, as you can see. This one way simpler. It contains only bidirectional chip for differential line, 3.3 volt stabilizer, and 120 ohm for line termination. And what also cool about this module, if we take a pin out and compare with my CNC controller that I made, you can see that pin out is the same. So we can solder an angled connector here and screw it just right in, like so. On the next pendant version, I probably will match this pin out to use those modules with angle connector on both ends. That's how it all turns out. So this is how it's soldered to twisted pair for wires to install inside pendant. On the other side, it's already in a heat shrink tube with pins to connect to controller, and this wire is a ground wire for shielding. I plan to connect it directly to ground that come from outlet. One advantage of my board compared to other off-the-shelf solutions, that my board is so small. It can fit to GX12 connector hole, so later I would be able to replace this solid cable with a cable with connector, and I wouldn't need to solder it in place. I would be able to solder connector and then sneak it through this hole. This is how it looks inside my pendant. As you can see, it's small, it will close without any problems. I need to make a cable relief there, but I will do it later. Pendant connected to controller. I dropped cable as I could in this mess. Moment of truth. We got power. I didn't mess up this part. We have communication. Great. So my board this works. And now servo. Not a single error. This works beautifully. I can jog without any, not blinks, not jumping numbers, nothing. Not communication error. Really cool. In conclusion, filter didn't help with communication issues, but it's still needed to avoid any EMI emitted back to the grid. Twisted pair, shielded, and differential signaling data transmission did the trick. Highly recommended. You can get board off the shelf as I did initially, or you can get mine, link in the description. Thanks for watching and see you next time. Bye. Bonus content. What's inside servo driver? As we can see, this is a huge board. It looks like it's a power board. There are all our voltage input and motor output. And this is a logic board. On this board we have settings, USB, we have inputs and encoder input. There are two huge chips, big chip GD32F4 and another big chip Pango something. It's this one ARM microcontroller, and this one is FPGA array. What else I could say about this servo driver? As you can see, here's a fan, very noisy, and it's go through those two chambers. If we take this part, we can see it's all covered except fan, and the other part it's all covered here and here. So even if this placed somewhere in a chamber where I do milling, those chips shouldn't get inside. What I slightly doesn't like about this servo driver, you can see like braking resistor that uses to dump energy as heat when motor has to be stopped, and this resistor placed on opposite side of this heatsink, and because of that those wires go right in a path of air, which may attribute some to noise.